Good morning, dear students. You are welcome back in Sanjeevanee Mahavidyalaya Chapoli in Department of Physics. This lecture is again for B.Sc Physics TY students, paper number 13A, Solid State Physics. Unit is Bonding in Solids and X-ray Diffraction, lecture number 3. In last lecture we have seen different bonds, that means ionic bond, covalent bond. In this lecture again we are discussing the secondary bond, that is hydrogen bond and metallic bond. What about hydrogen bond? What about metallic bond? And what is the importance of hydrogen bond in our day-to-day life? All these things we discuss. And in case of metallic bond, what are the factors affect the strength of metallic bond? Here, number one, total number of delocalized electrons. Next one is magnitude of positive charge held by metal cations. Next one is, third one is ionic radius of the cation. These are the factors affect the strength of metallic bond. Now let's turn to a secondary bond, that is hydrogen bond. A hydrogen bond, it is also known as H bond. Hydrogen bond is a primarily electrostatic force of attraction between hydrogen atoms. It is a primarily electrostatic force of attraction between hydrogen atom. The hydrogen bond is responsible for many of the anomalous physical and chemical properties of compounds of sodium, oxygen and fluorine. The hydrogen bond is an attractive interaction between a hydrogen atom from a molecule or a molecular fragment XH, in which X is more electronegative than H, and an atom or a group of atoms in the same or different molecule. Hydrogen bonds can vary in strength from weak 1 to 2 kilojoule per mole to strong 161 kilojoule per mole in the ion HF. The hydrogen bond exists with water H2O. The oxygen has two lone pairs of electrons, and on top of this it is a partially negative, making the hydrogen partially positive. Hydrogen bond is the bond formed from an oxygen atom in one molecule to a hydrogen atom in another molecule. Let's see diagram so that this concept will be clear. Each oxygen has two hydrogen bonds, whereas each hydrogen has one hydrogen bond. See, each oxygen has two hydrogen bonds and each hydrogen has one hydrogen bond. Hydrogen bonds happen with other covalent molecules with an electronegative atom, like ammonia, NS3, and hydrogen chloride, HF. See her figure. hydrogen bond in water molecule. You see here, hydrogen bond in water molecule, here it is. Oxygen and hydrogen, they are connected. So in this way, hydrogen bond exists in oxygen and hydrogen in water molecule. Here I will show you figure, that is HF, hydrogen fluoride. What is there in figure? Hydrogen bond is between hydrogen and fluorine. Hydrogen is a positive dipole, whereas fluorine is a negative dipole, and hydrogen bond exists between two oppositely charged dipoles. Hydrogen is positively charged, fluorine is negatively charged dipole. So between these positively charged and negatively charged, oppositely charged dipoles, hydrogen bond exists. Here it is shown in figure also, this color picture. Low electron density here, that is positive dipole hydrogen. High electron density here, fluorine, that is negative dipole. And there exists a bond between this positive dipole and negative dipole, that is hydrogen bond. In this way, hydrogen bond exists in between oppositely charged dipoles. Importance of hydrogen bond. See, there is a lot of importance of hydrogen bond in our day-to-day life. Hydrogen bonding is very important because it is crucial to all life on earth. Then you may ask how. There are three reasons about importance of hydrogen bonding. First one is the DNA, structure of DNA. Biological example is what? Structure of DNA. DNA has double helix structure because of hydrogen bonds. Hold together the base pairs in the middle. Base pairs hold together in the middle due to hydrogen bonds. That is double helix structure. Without hydrogen bonds, what happens? DNA would have to exist as a different structure. This is a biological example. So because of this hydrogen bond, double helix structure DNA has, and hydrogen bond hold together the base pairs in the middle. Now let's turn towards one more example. Second reason, the specific heat capacity or boiling point of water. You are familiar with the concepts specific heat capacity and boiling point of water. You are well known that boiling point of water is what? 100 degrees Celsius. What is meant by boiling point? You know, boiling point means what? Whenever heat is provided to water, it absorbs heat, and one stage will reach, temperature goes on increases, and at one particular temperature, water begins to boil. Water begins to start to boil, or it turns into vapors at a constant temperature. Then further temperature will not increase. So at a particular temperature where the water boils or converts from liquid to vapors, that constant temperature is said to be boiling point of water. And you are well known that boiling point of water is 100 degrees Celsius. but it is because of what? Hydrogen bonding. Water has a relatively high boiling point due to hydrogen bonds. What happens if the hydrogen bonds are not available? I mean, without hydrogen bonds, water would boil at about minus 80 degrees Celsius. You imagine. If water boils at minus 80 degrees Celsius, then what happens? Then storage in the seas, so storage in the ocean, they may get evaporated, and what happens? There is a lot of scarcity of water on the earth. So water in ocean and lakes would rapidly boil away. If there is absence of hydrogen bond, then what happens? It will happen that water in oceans and lakes would rapidly boil away, gets evaporated. This would cause massive problem for life on the earth. So hydrogen bonding is very important. Water has relatively high boiling point due to hydrogen bonds. And without hydrogen bonds, surely what happens? Water may boil below 100 degrees Celsius. It means up to minus 80 degrees Celsius it starts to boil and water gets evaporated. And this will cause a massive, large problem for life on the earth. One more example is there. Third is structure of proteins. This is again biological example. Proteins. Hydrogen bonds are important in forming secondary structures of proteins. Proteins, it is used the helix and the plated sheets. The hemoglobin molecule consists of 4 subunits. The proteins in the subunits are coiled into helices that are held together by hydrogen bonds. And if no hydrogen bond is there, I mean without hydrogen bonds, to keep its shape, hemoglobin would be unable to function. To keep its shape, to keep its shape, hemoglobin would be unable to function without hydrogen bond. So these are the three main reasons. These are the three beneficial factors. These are the three examples of benefits of hydrogen bonding. So we have seen because of hydrogen bond, boiling point of water is raised. Otherwise, the water could boil at minus 80 degrees Celsius. And because of this, what happens? Oceans and lakes may, what happens? They may get vanished. Water from the oceans and lakes may evaporate early. There is a lot of large problem, massive problem for life on the earth. Similarly, the structure of proteins and DNA also. So these are the various reasons. Now these are the various benefits of hydrogen bonding in our day-to-day life. The remaining matter we discuss in next lecture, that is bonding in solids and X-ray diffraction, lecture number 4. Thank you.